Hello, very good morning to everybody. Welcome back to my usual lesson slide. Okay, I'm Mr. Chu, as you already know. So today we are going to start with a brand new chapter, which is chapter 6b, acid-base and solubility equilibria. Okay, so before I begin my lesson, if you like my video, please help me to click the like button. And if you want to receive a further notification, you can always subscribe to my channel and press the notification button to receive the latest update. So with the next session, let's begin our lesson today. Okay, so what is the pH of the solution obtained when 25 centimeter cube of 0.25 mole per decimeter cube sulfuric acid is added to 200 centimeter cube of 0.400 of sodium hydroxide? So basically in this question, you have to know on how to calculate the amount of the H plus and also OH minus. So you have to first calculate the mole respectively. So the mole of the sulfuric acid is, you use MV over 1000, 0.25 multiplied by 250 divided by 1000, you get 0.0625. But stoichiometrically, 1 mole of the sulfuric acid make 2 mole of the hydrogen ion, so the hydrogen ion will be 0.125 mole. As for the mole of the hydroxide ion is 0.400 multiplied by 200 divided by 1000, you get 0.08 mole. So in here, sodium hydroxide is the limitant, since you have a limited amount of the number of mole. So how much is the mole of this hydrogen ion in excess? So 0.125 minus 0.08, you get 0.00425. Then you have to recalculate to become the concentration. So concentration is 0.0425 times 1000 over 250 plus 200, you get a 0.1. So negative log 0.1, you get 1. So the answer for the number 1 is B. So number 2, water is a weak electrolyte which undergoes autoionization according to the equation below. 2H2O give H3O plus OH minus. If the concentration of water is C and the degree of dissociation is alpha, which one of the following expressions are correct? So because water is neutral and Kw is equals to OH minus times H plus, so this will lead to H3O plus equals to OH minus for a neutral solution. And through certain expression, if you already noticed previously, you can eventually get Kw equals to Ka times Kb, and H3O plus is equals to C alpha, and pKw equals to pH and pOH. So in here, all the 4 equations here can be derived out from this expression of the ionic product of water. So all 1, 2, 3, 4 are correct. Then it goes to number 3. What is the pH of the buffer solution when 250 centimeter cube 0.1 of ammonia is added to 250 centimeter cube of ammonium chloride of 0.25? So because you're adding volume to volume, you have to recalculate the concentration. So the concentration after the recalculate, you get pOH equals to negative. You use the this buffer solution equation. pOH equals to pKb minus log concentration of the base over the salt. So you have pOH minus negative log 1.8 times 10 power negative 5 minus the concentration of the weak base over the salt of the weak base. But in here, since we see that the volume is the same, so you are going to expect it to have the same concentration of the salt. So pOH is equals to 5.14. So pH minus equals to 14 minus 5.14. You get 8.86. So the answer is C. Number 4, in which of the following equation does OH minus act as a conjugate acid? So in here, conjugate acid comes from a Bronsted Lowry base. So in here, water must act as a base. So NH3 act as a base, H2O act as a Bronsted Lowry acid. So A is not the answer. HS is also a base because you become H2S. So you accept proton. So therefore, H2O in here is acid. NO2 to become NO2 plus, we can see in here, NO2 accept proton, so it becomes HNO2 plus. Therefore, H2O here act as acid. But finally, the O2 minus plus H2O, where the H2O act as the base, donate the proton to the O2 to become OH minus. So in this case, this OH minus for both sides act as a proton accepted and also become the conjugate acid and conjugate base at the same time. So in here, the best answer is donkey D. Then we go to number 5. Titration curve of an acid-base reaction is shown below. We have pH against volume. Which of the following acid-base titration will produce such curve? So if you notice carefully, the points is in alkaline. The neutral point is at the alkaline. So this must be a mixture between the strong alkali and weak acid. Strong alkali and weak acid mixture. So among the choice, strong alkali and weak acid mixture is A. Then we go to number 6. In the reaction, Ni2 plus 6 NH3 give NiNH3 plus. So what is the role of the Ni2 plus? So it seems that Ni2 plus in here accept the electron pair from the ammonia, hence form the complex. Therefore, nickel in here act as a Lewis acid in here. Okay. Number 7, H indicator, HIN indicator acid is an acid-base indicator which is red in the molecular form and yellow in ionic form. The dissociation constant of this indicator is 1.0 times 10 power negative 4. What is the color of this indicator at the solution equals to pH 7? So in here, when there's pH 7, where pH is much greater than the pKa, or basically P indicator. So indicates that the base is more than acid, therefore equilibrium will shift more to the left, showing the acidic color. So in this case, we show it as a red color. Okay. So this is what it means in here. And then number 8, the value of the Kb for the several substance are given in the following table. So you have this following Kb. Which of the ion has the strongest acid? So strongest acid is made from the weakest conjugate base. So weakest conjugate base will have the lowest Kb value. So the one with the lowest Kb value in here is the aniline, 9.4 times 10 power negative 8. So therefore, the strongest conjugate acid is benzene ammonium ion. So that is for question number 8. And then we go to number 9. Which one of the following is the most appropriate chemical indicator to use for the titration of 0.100 HCl and 0.100 NaOH, where NaOH is a titrant in here. So because this is a strong acid, strong base titration with equal number of mole, so this effective pH range for the indicator works are actually quite large, because the endpoint in here is also quite large. So what are the suitable indicators? You can use Timo blue, you can also use bromo Timo blue, you can use phenolphthalein, and you can also use cresol red in this case. So all of these indicators are accepted to be used as the indicator. Then number 10, SO2 can react directly with OH minus forming HSO3. In this reaction, what is the role? So SO2 which act as the lone pair electron acceptor from the OH minus, hence form HSO3. So SO2 in here will act as a Lewis, OH minus here act as a Lewis base, relating the electron pair to SO2. So in this case, it seems that the SO2 in here act as the Lewis lone pair electron acceptor. Therefore, it's the Lewis acid. H indicator is an acid-base indicator which is blue in molecular form and yellow in ionic form. The dissociation constant of this indicator is 1 times 10 power negative 4. What is the color indicator in here? So very similar to what we have answered just now. So since inside the if you have a greater pH value, that means it is much greater than the indicator. So it shows the basic color, so which is the acidic indicator color in this case. So the acidic indicator color in this case is blue. Okay. Okay, then number 12, the value of a Ka for several substances are given in the table below. So you have this following value. Okay, so which of the following is the strongest base? So strongest base comes from the weakest acid. So since phenol is the weakest acid, therefore it has the strongest conjugate base. So the best answer in here is C. 13. Buffer solutions are very important chemical to a biological system. Calculate the pH of a buffer solution by mixing 100 0.5 ethanoic acid and 50 0.2 sodium ethanoate. K is equals to 1.7 to 10 power negative 5. Now, since you are mixing volume with volume, you have to recalculate the concentration of both acid and also salt. So after recalculating the concentration of acid and salt, you substitute in the buffer solution equation, where you have negative log 1.7 times 10 power negative plus actually, when you use plus, is plus salt over acid. When you use minus, is minus salt over base. So in this case, is a minus. I'm so sorry, I showed the wrong formula. It's supposed to be minus. Okay, yes, with that. Okay, minus log 0.3 and 6.7. So at the end of the day, you get 5.1. Sorry for that typing error, but the answer is C here. Okay, so that is for question number 13. Then we go to number 14. Ethanoic anhydride is hydrolyzed according to the equation CH3CO2 plus H2O give 2 CH3COH. 0.05 mole of ethanoic acid anhydride is added to 1.0. After reaction complete, the solution has the pH value 2.87. So what is the value of dissociation constant of acid? So if you notice carefully in here, the acids come from here. However, this reaction is reversible, means that it is not 100%. So if you want to calculate the pH of the solution, first you have to calculate the concentration of the H plus by using the pH. So pH is negative negative log H plus, or H plus is equals to anti-log of the 2.87, you get 1.35 times 10 power negative 3. So we know that the dissociation HA give H plus plus A minus, so K is equals to Ca square, acidic square divided by the concentration of the acid involved. So K is equals to 1.35 times 10 power negative 3 square divided by the concentration of the acid. So 0.5 mole of ethanoic acid divided by 1.00 times 2, because you form 2 ethanoic acid. So you get 1.82 times 10 power negative 5. So this is basically the way. There is a little tricky part in here where you need to understand about the methods to get to the concentration of the acid in this case. Okay, so that is for number 14. Number 15, in aqueous solution, chlorate 1 ion ClO minus are hydrolyzed according to the equation. What is the pH value of a 2.00 times 10 power negative 2 mole per decimeter cube solution of sodium chlorate NaClO at 25 degrees Celsius? Okay, so given to you, Kb is 3.3 and the ionic product is 1.0 times 10 power negative 14. So in here, you first need to calculate from the Kb equals to HClO times OH minus gives ClO minus, or Kb is equals to OH minus square, since the dissociation of HClO and OH minus are the same. So therefore, OH minus is equals to 3.30 times 10 power negative 7 multiplied by 2.0 times 10 power negative 2 square root. So OH minus is equals to 8.1 times 10 power negative 5. POH is 4.09. So pH is equals to 14 minus 4.0 again, you get 9.91. So that is how you solve for number 15. As for 16, which underlying molecule react as a Lewis base in here? So Lewis base in here is an electron pair donor. So electron pair donor in this case, you have to allow the CH3Cl donate the electron pair to the FeCl3 to form the complex. So therefore, in this case, there are no answer in here. I underlined wrongly the question, so pardon me for that. Okay. Okay, never mind. We continue. Number 17. Aqueous solution of monobasic acid has a pH 3.5. 25 centimeter cube of volume of an aqueous solution of acid completely neutralized 27 of 0.1 sodium hydroxide. So what is the this one? Ka. So pH is equals to 3.5. So concentration of H plus is 3.16 times 10 power negative 4. So let the concentration of the monobasic acid is C. So 25 times C divided by 27.5 times 0.1. So concentration of C equals to 0.11 mole per decimeter cube. So H plus is equals to square root of Ka times C. So Ka is 9.08 times 10 power of 7. So the answer in here is C. Then number 18, when solid ammonium chloride is added to excess in the aqueous solution of ammonia containing phenolphthalein as indicator, so what will be formed? So a weak base and the salt of the alkaline form a buffer solution. So a buffer solution is formed. Then number 19, the equilibrium constant for two equilibrium systems are as follows. You have dimethylamine CH3 2NH plus H2O gives CH3 2NH2 plus OH minus. You get a Kb is equals to 5.4 times 10 power negative 4. And then you have another expression NH2OH plus H2O give NH3OH plus OH minus. So which statement about the species in the reaction in true is here? So Kb for the first system is greater than the second system. So this will mean CH3 2NH is a stronger base compared to NH2OH. Therefore, in terms of the conjugate acid, so NH3 2NH plus 2 is a weaker acid than NH3OH. So that is for number 19. Then number 20, which pair will yield a buffer solution with a pH value about 11 when the solution of equal volume and concentration are needed? So in here, when you have a pH above 11, then it must be a basic buffer solution. So for a basic buffer solution, you are required for a weak base and a salt of weak base. So in this case, A and B are weak acids, C and D are weak base, but D has this CH2H5 and H3Cl as the salt in here. So therefore suitable to be used as a buffer solution. So the answer for number 20 is donkey D. 21. Lead 2 chromate PbClO4 is a yellow pigment. The solubility product of PbClO4 is 25 at 25 degrees Celsius is 2.8 times 10 power negative 13 moles square DR minus 6. What happens if a few drops of aqueous solution of the lead 2 nitrate is added to the saturation PbO4? So it is due to PbClO4 give PbCl2 Pb2 plus ClO4 2 minus. So addition of the lead nitrate give a common ion effect, which cause the ionic product to be lesser than KSP. Therefore, PbClO4 form will be precipitated. Okay, so in this case, the concentration of the dichromate ion is compared to the concentration of the lead 2 nitrate added to the solution. So once you get the mathematical works done here, so you get concentration square root of 2.8 times 10 power negative 13, you get 5.29 times 10 power negative 7, which is far greater than the concentration of the dichromate ion. So that is why here concentration of ClO4 is lesser than 5.29 10 to the power negative 7. Okay, so that is for number 21. As for 22, the mixture of citric acid and sodium citrate as a buffer solution, which statement is not true for the reaction? A, dissociation of acid increase with the presence of alkali. So dissociation may take place, but so therefore equilibrium shift more to left, but not to the right. Okay, citric acid react with OH minus in the presence of alkali. In this case, there are no possibility where OH minus may also react with the citric acid, but not with the sodium. So under the H plus, citrus ion will react with the CiH. So the best answer in here is Na plus react with OH minus in the presence of alkali, which is totally wrong because Na plus and OH minus are far too apart from each other. Then we have 23. A saturated solution of calcium hydroxide CaOH2 has a pH value 12.2. What is the numerical value of the solubility product? So in here you use CaOH2, you Ca2 plus OH minus. Since the pH of the solution is 12.2, so you get the pOH to get 1.5. Then you get the after you get the mole of the hydroxide ion, which is 0.0158 mole per decimeter cube. So you have to know by yourself stoichiometrically 2 hydroxide ion form 1 calcium. So calcium's concentration is 0.0729. The value of KSP is 3.2. Value of the KSP for Ca2 plus OH minus in here will be 0.79 multiplied by 0.0158 square. You get 1.99 times 10 power negative 6. So the answer is A. Okay, 24. The equation for autoionization methanol is shown below. So which statement is true? So in here, autoionization, it shows the acid, it can act as an acid as well as a base. So therefore it shows amphoteric behavior. Okay, 25. Phenolphthalein indicator is suitable to use for titration. So usually phenolphthalein is at the basic range. It is suitable for strong acid, strong base, weak acid, and strong base. So in this case, it is somewhere between NaOH with HCl. So that would be the best in here. As for B, even though it is a weak base, but because H2SO4 is a diproctic acid, so you have two different endpoint. Both of them will not intercept 7 point phenolphthalein indicator. Okay. Okay. So with that, the best answer in here is A. Then 26, which one of the following affects the value of solubility product of silver sulfate? So the only factor that will influence an equilibrium change are only temperature. Okay, so therefore this answer is A. Number 27, public swimming pools are often chlorinated to kill bacteria. An alternative to chlorination of silver ion can be used in concentration so for more than 10 power of negative 6 and not less than 10 power of negative 7 of silver ion. Which compound would be in saturated solution provide the necessary concentration of the silver? So in this case, we want to look for a solution which started to form precipitate. So after we calculate the solubility for each silver react with the compound, you have AgBr 7.07 times 10 power negative 7, AgCl 1.41 times 10 power negative 5, AgIO3 form 1.41 times 10 power negative 4. Then the silver carbonate will be 3.12 times 10 power negative 4. So in here, it seems that the silver bromide fulfill the requirements for this one. So therefore, the best answer in here is A. Number 28, endpoint of the reaction between 0.1 of acid graduate changes with 10 centimeter cube of the alkali. So which of the following substance could have giving this following result? So in here, you can see from the endpoint here, again, it is at the basic range. So when it is at the basic range, so you should expect to have more higher degree of dissociation of the hydroxide. So in here is it's D in here. Okay, so why A, B, and C are not suitable? Because they are this diproteic. Okay, they are diproteic. So when they are diproteic, you expect to have two endpoints, but in this case, it's only one endpoint. So it must only be one stage reactions in here. So the best answer in here is D. 39. Hardness in tap water can be determined by titrating a sample against a reagent which form complex ion with dissolved metal ion. So the indicator for this titration require pH to maintain about 10. Which of the following in aqueous solution can be used for this? So it must be measured in between weak base and the salt of the weak base. Okay, so the following combination of ammonia and ammonium chloride will be the best. Number 30, the pKb value of aqueous ammonia is 4.8. What is the correct pKa value of the ammonium? So pKb equals to 40 minus pKa. So settle it for a while, then you get your answer is 9.2. So I believe that is all for the objective questions discussion. So if you have any questions, you may leave a comments and I'll try my best to answer as fast as I can. Okay, thank you very much.